section called batteries, like conductors and insulators. Okay. So, what you can understand about conductors and insulators? You see, as the name implies, conductors it conduct electricity. Insulators it doesn't conduct electricity. Okay. So it is going to block the passage of electricity in a particular circuit. See, for instance, we will go from a small picture in which you see the battery. So this is a battery. So let it be, this is a positive terminal, this is a negative terminal. So if the battery is passing through, let this be the bulb. So this is a bulb, and this is connected to, so this is let it be, this is a graphite rod. So this is going to connect here. Okay. So now let's see what is going to happen. And there is, of course, there is going to be a switch. When the switch is switching on, when you are going to switch on, this is a switch. Okay, so let this be the switch. So this bulb, it is going to glow. Okay, the bulb is going to glow. And do you know the reason? Actually, when you are switching on the bulb, actually this electrons, it is going to pass from one direction. It is going to pass from this direction, from negative terminal to, positive terminal. It is going to pass through from negative terminal to positive terminal. And actually these electrons, it will pass through this graphite rod also, because graphite is a very good conductor. And it allows the passage. Actually, this electron passage, this electron migration, it will be allowing through the graphite rod. Okay. And so what you can understand about graphite rod is actually, this is actually, it is a good conductor. So it allows the passage of electricity. Okay. On the other hand, if you are going to keep instead of graphite rod, let it be, you are keeping some plastic bottle, let it be. You just remove it. Instead of this graphite rod, you are keeping a plastic bottle. You think that this is a plastic bottle. You connect it here. So this electrons, it shall be passing. And till here, till the bulb, it will be passing. Okay, but it cannot complete the circuit, because through the plastic bulb, the electrons will not pass through, because actually this bulb, electric bottle, this electrons will not pass through, because this electric bottle, this is nothing but, this is going to be an insulator. It doesn't allow the passage of, it is not going to allow the passage of electricity. Okay, so this is something you have to be clear actually. We can easily check whether something is allowing the passage of electricity or not allowing the passage of electricity. We can connect that substance in the electric circuit. If the bulb is glowing, or if ammeter is showing any reading, that is going to be a conductor. If no signal, no bulb is glowing, that is going to be a insulator. So this is the difference. Actually, a conductor, it allows the passage of electrons, but an insulator, it doesn't allow the passage of electrons. So this is the prime difference between a conductor and an insulator. Okay. Now we can see some of the uses of conductors and insulators. See, suppose if you see anything in the nature, sometimes certain things it is going to be useful in a particular application. So for instance, if you see the cow dung, that is a very good manure. You can use as a fertilizer. It is a very good manure. On the other hand, you cannot use a cow dung for pasting on the wall, right? So each have different aspects. For pasting on the wall, you can use a paint. The same way, this conductors and insulators, each one will have its own applications, its own purposes. For example, if you see the wire, okay, and you can check, in fact, the wire, if you check it, inside the wire. So, inside the wire, this is going to be some, insulator tape. Mostly polythene or like a polythene will be the polythene cover will be there. and this is going to be the copper wire. Okay, so this is going to be the copper wire. Okay, so the electron flow, actually the electron flow, it will be happening through this copper wire. Actually the electron flow will be happening through the copper wire. But and you may tend to ask, obviously we all know why there is a sheath, why there is an insulator material above that. Suppose if you directly touch on this copper wire, then what will happen is you will get the electric shock. Yeah, you will be shocked. But on the other hand, there is an insulator, means okay, it's good, like you can just touch with your bare hand. But of course, it is always advisable not to touch it when there is an electric circuit is flowing, because you will never know when there is a cut, when there will be a cut in this area. So what you will do? Nothing you can do. You will be exposed to electric circuit. So as a cautious manner, it's better not to touch it. And next one, the one which you will see in this 11 kV lines. So 11 kV lines, this is going to be a wire, and surrounded by there is another wire. This is actually, so this is actually copper wire. So it is surrounded by steel wire, steel cable. Okay, so this copper wire also is conducting, and the steel is also conducting. Okay, and steel is also conducting. And why we are using steel supporting to copper wire is because steel is very strong. It doesn't allow the this copper wire to get broken. Okay, so this is a very important thing. And you also know how is the stand. I mean, what is the exact word for that is pylon. Pylon. Okay, you can see the picture of pylon here. You can see the pylon. Actually, in the pylon, okay, these are actually these are actually ceramic disc. Okay, so it is nothing but ceramic disc. Actually, why there is a ceramic disc in that? Because ceramic is actually a very good insulator. So it doesn't make the pylon to lose a lot of electricity or electricity in the form of heat. And this pylon material, I mean, how is will prevent, it will prevent the flow of electricity to the pylon. If flow of electricity to the pylon is happening, if you touch it, that person will die. It is a very dangerous thing. So that is the way, how insulator and conductor will comes into play. Conductor is good when there is a need for conductivity, when there is a need for conducting electrons or electricity conduction. Insulator is good when you want to protect, when you want to block the current to pass. Okay, so different aspects will come into play, different versions will come into play. Okay, some of the substances it is conducting. I mean, what are the common substances it is conducting? See, and in order to check, as I told you, in order to check if a substance is conducting or not conducting, you can also do it as an experiment. You just take a battery. No need to connect to the household electric supply. You can just take a battery, and so let it be a battery here. Okay. Okay, let it be a battery, and you are connecting it through a bulb. And so this is a okay. So this is a electric supply. Actually, as you can see, the electrons, it is going to pass through the bulb. Okay, and so it is actually the electron flow will start from negative terminal to it is going to start in the positive terminal. It ends in the positive terminal. Okay, so this bulb it shall glow, and this is actually a you can say a tin wire. So what you can understand about this is when the bulb is glowing, that means the electron flow it is very complete. Okay, it is directly passing. Once if there is the flow is continuous from positive to negative terminal. Negative to positive terminal is completed, then only the bulb will be glowing. Then only the electric circuit can be completed. So since this is a tin, like it is what you say, it is going to be, since it is conducting, the tin is conducting. Okay, what you can understand is the bulb will be glowing. But on the other hand, you are just replacing. Okay, you just take the next circuit instead of okay, you connect this into, so let this be the bulb. Okay, so this is a solution of, okay, so this is a positive, this is a negative terminal, and this is a positive terminal. Okay, so and this is a graphite rod. This is a graphite rod actually, and so this is going to be ethanol solution. So our intention is to check whether the ethanol is conducting or it is not conducting. So and I switch on the bulb. And the electrons started flowing, but there is no electron flow after this. So the circuit is not complete. So and the bulb is also not flowing. What that means is ethanol is not conducting. Ethanol doesn't conduct electricity. It is not a conductor of electricity. And you just replace it with the, so in the next circuit, okay, instead of this ethanol, you just you are taking, okay, I don't want to draw one more circuit, okay, I am just telling you. So you are taking lead bromide crystals. Okay, so this is lead bromide. So if you are connecting this circuit, there will not be this bulb, still it will not glow when you are having a solid lead bromide. On the other hand, so you are just melted it. Okay, you just melted it as you can see this is going to be a melted lead bromide, melted molten lead bromide. Then in that case, this bulb will glow. But there is one issue here. When the bulb is switching on, through this lead bromide, molten lead bromide, you can see that some brown color, bromine vapors it shall be coming. Brown color actually bromine vapors it shall be coming. Do you know what is happening? When the electricity passes through this lead bromide, it is going to dissociate into, Pb2 plus Br minus. This 2 Br minus, it will changes into Br2. Okay, this lead 2 plus, this is going to change into, we will talk in detail about the electrolysis. Lead Pb2 plus, it is going to change into Pb. Okay, so what we call this process as electrolysis, I mean like the splitting of bond with the help of electricity, that is called electrolysis. Okay, so and so this is the thing, like this is what it is. So an electrolysis, electrolysis is a breaking up of bond, breaking up of molecules, so that is what is called electrolysis. And so this bromine vapors, it shall be coming, it shall be releasing, it shall be getting released. And so what you can understand, this molten lead bromide, that is going to be a very good conductor. It's a pretty good conductor. It allows the passage of electricity. Okay. So let's see some of the conclusions what we got from the results so far. The first one is, the what are the conducting things are, solids and graphite. Okay, solids and graphite. See, usually the solids, if you see the metal solid standard, okay, consider a metal. So, this is going to have free electrons actually. It contains a C of, it contains a pool of electrons. Okay. So this is negative and positive terminal. So this is a battery. Okay, this is a battery. Like when there is a, battery is connected to the metal. Usually, what will happen? The electrons flow from negative terminal and it goes through positive terminal. Okay, it goes through positive terminal, and what shall happen is, you know, this when it is this electron flow comes in the metal. Okay, so you know, an electron comes flow in the metal, you know, like there will be a pull of electrons through the metal end, and this shall happen. I mean, like the flow of electrons will be happening through the metal. Okay, so and the same is true with the graphite also. Graphite also, it contains a pool of electrons. You know, like when there is a pull, when there is a potential difference, you know, the electrons, it shall be migrating from one end to next end. Okay. And on the other hand, you know, if you check another conclusion, what you can make is, if you check let it be plastic. Plastic is a molecular solid. So you see some ice cubes. Of course, ice will be melting, and you check any other molecular solid. So let it be plastic itself, plastic, or other than graphite. Okay, yeah, let it be carbon black. Of course, some of the carbon black, it will be conducting, and let it be wood. Yeah, even not wood, and yeah, let it be, the common example is a plastic. Okay, so you know, plastic, you know, if I am connecting it to this is a plastic, let it be, and it is connecting to negative and positive terminal. Okay. It is connecting to, you know, there is this does not contain electrons, so there will not be any flow of electrons will be happening in this plastic. Okay, no flow of electrons will be happening, and no migration of electrons will be happening. So since it does not having free electrons or mobile electrons, so this plastic does not conduct electricity, right? So any substance if it is having mobile electrons, okay, it is going to be a conductor. And when you are taking ionic solids, okay, consider an ionic solid, let it be, okay, let it be, you know, potassium chloride. Okay, so this is potassium chloride. Let it be potassium chloride. This is nothing but an ionic solid. So what should happen, you know, if you are connecting a negative and a positive terminal, okay, there will not be, you know, if you connect a bulb, this bulb will not glow. There will not be, no glow of a bulb will be happening. No glow of a bulb will be happening, because in the molten state, in the solid state, no ionic solids will be conducting electricity. No conduction of electricity will not happen in the ionic condition, in the solid condition. On the other hand, think that, you know, you are melting. Okay, you just heated it, and you are melting. You know, this shall converted into ions. Obviously, this potassium chloride, it will have a K plus and Cl minus ions. Both of these ions, it carry the charges. So due to the migration of charges, the electricity conduction shall be happening. And you know, electricity conduction, it shall happen. It shall happen in that way. Okay. So the migration of charges is responsible for the electricity conduction, right? And then, you know, then what is the next thing is, yeah, see, then, you know, another conclusion you can understand is, when you are passing electricity to this molten type of condition. So for example, you are having K plus and Cl minus, K plus and Cl, potassium chloride, molten, let it be, you are having liquid condition. Okay, so this is a molten condition. When you are passing electricity, you know very well that what shall happen. See, for example, this K plus, you know, this is going to change into you know, potassium plus chlorine gas. This potassium, it will go to cathode, and the chlorine gas, it will you know, it will end up as a product in anode. Okay, so it will go to cathode and it will go to anode. So in the cathode, the potassium ion will be depositing. In the anode, chlorine gas will be depositing. Okay, and yeah, so this is the same. Now these are the conclusions. Let me repeat. You know, the conducting substances in the nature is actually, if you compare the conducting substances versus non-conducting substances, I can confidently tell you that non-conducting substances are more, because you see the plastic, wood, and brick, this paper or cloth, anything. Most of the substances on the earth, it is not conducting. Of course, we are secure. We should be happy in that, because whenever there is a thunderstorm, there is high probability that electricity will be passing through iron or copper or such kind of a through the conducting substances. Electricity shall pass, but not through the non-conducting substances. Even we are not conducting when we are pure. When there is set particles or ionic substances are on our body, we will be conducting. In that situation only we should be careful, and we should not touch any conducting substances with our any electricity passing substances with our bare hand, because our hand will have more amount of ions will be there due to the set and due to the electrolytes in our body. Okay, so this is the reality, and next aspect is most of the molecular solids. Say ice, say let it be charcoal, let it be, so many of the molecular solids are around us, that is composed with the molecules. Let it be solid carbon dioxide, and similarly similar substances. So those substances are non-conducting. So let it be solid phosphorus. Solid phosphorus doesn't conduct electricity. Okay, and that is again another aspect. And the third aspect is when electricity passes through molten ionic substances, it is going to decompose and it is going to release its corresponding products. Okay, so this is the reality. Thank you.